All right, atomic structure. First two, super easy, right? AR. Okay, AR is our relative atomic mass. You sometimes going to be see it written as R.A.M or RAM, but primarily for AQA, we're going to be looking at AR. Okay, very similar to relative formula mass, MR. All right, but this is going to be for specific atoms. Okay, now relative atomic mass equals when you're giving your data, right, for the mass spectra, you may be given it as a chart, so an actual spectra. You may be given it as data in a table. You may be given it as just variables written down within the question, okay? They're going to come in only two forms, okay? And the equations are exactly the same. So what I'm going to do is I'm going to write out what the equation is to begin with. Isotopic mass, or isotope mass. What is the mass of the isotope multiplied by something divided by 100, okay? The second one is exactly the same. What is our isotope's mass multiplied by something divided by something else, okay? So I'm going to tell you, if you're given the percentage abundance, you're going to be using this equation 1 divided by 100. The reason you divide by 100 is because it's a percentage, okay? So we want to get rid of that. Now, our relative abundance is our second form that the variable can be given. So if we have our variable as relative abundance, are we going to have 100 as the denominator here in our fraction? No, we're not, okay? Because we're not dealing with percentages. So the bottom is just going to be our total or sum of the relative abundances. Okay, and that is going to be the first two equations. Super, super easy stuff. Do your best to remember these. Primarily, they're going to be giving you the percentage abundance. I've seen that the most, I think, for AQA, but they will also give you the relative as well. Now, be careful because sometimes you're going to have to use algebra because there's going to be unknown percentage abundances. So you have to realize that the total percentage abundance is 100, and then you minus whatever the known percentage abundances are to give you the unknown percentage abundance, and you have to solve it accordingly. Just practice some questions in some past papers for AQA, and you'll see exactly what I'm talking about, but I'm not going to go through the actual steps of the calculations in this video. It's just the formulas you need to know, okay? Time of flight mass spec. So you guys in AQA are kind of unfortunate. The other examples don't do this. You're going to have KE equals, I'm going to go through each of these, what each of these stand for, half mv squared. Some of you may even know what this is. Hopefully you do, all right? If you're revising this, you know exactly what this is. The second equation, you can remember it in a few different ways, okay? This one right here is going to be given to you in the question, okay? This one is not, okay? And the easiest way I remember this is V equals D over T, okay? Now, let's go through what each of these are as well as their units. This one is kinetic energy. Okay, so all of the ions that go through the time of flight mass spec, they are going to have been accelerated to a constant kinetic energy. So they're all going to have the same kinetic energy. So what's the unit going to be here? Our energy unit is joules right here. Okay, half, I'm not going to go through that, it's just half, right? M, this is mass. Okay, do your best to remember this unit, okay, because it's unique. Kilograms. That is our unit right here, kilograms. Everything in chemistry basically for mass is going to be grams. And this catches a lot of students out if they haven't revised this topic again before the exam. So remember, kilograms and you're all good to go. This right here is velocity. Okay, or speed. They're going to use them interchangeably, you know, but not a fan, but there we go. Meters per second is our unit. Okay, now this velocity from this equation is the V in this equation, okay? So what you're going to have to do oftentimes is work out what velocity is or input d over t directly into here. So it would become, let's find some space for this, it would become Ke equals half m and then d over t squared, okay? If you don't know what anything is, and then you're going to have to make d over t one variable on its own. Okay, you may be confused. I'm not going to go through why or solve a question. I have plenty on my channel to solve these sort of time of flight mass spec calculations, but that is basically what you want to do. Okay, so this and this is the same units. We're not dealing with anything else here. This is distance. Okay, D is distance, and this is going to be the length of the flight tube. So length of flight tube. So if they ask you what the length of the flight tube is, realize this is distance, okay? There is a unit for this. If we look at our units for velocity, it's meters per second, right? Which is exactly the same thing as meters per second. Meters, length, divided by time, seconds. And that is our velocity. So if we want to know what our units of distance is, the length of the flight tube, it's going to be meters. Okay? Pretty simple. Hopefully that makes sense. Time in seconds. Easy stuff, guys. Okay? Do your best to remember these. This is every equation you need to know for atomic structure. Good luck. If you want to grab yourself a free PDF formula book, check out the link down below. And you're going to be able to grab all my free resources as well. If you're struggling with Chem and you need that little bit of extra help to boost your grade as quickly as possible, check out my tuition offers. But regardless, this video should help you and put you in a good place to solve all the calculations you need to.